Hello everybody, here's Mr. C. It's Friday afternoon and I'm hanging out here in Yosemite Valley enjoying the waterfall up here and the nice meadow there. It's not true really. As you can see, I'm in my office, it's just my monitor. And what I'm really doing is I'm looking at the first labs that come in for the Diffusion Lab 310, and I see that some of you are struggling with the table and the graphing. So I want to give you a short screencast on how to do that. For the lab itself, I'm referring of course to the recording we did on Wednesday for the direct instruction. Here's your lab report, right? And it starts out with this table that you have to fill out here. Here's your example, and you can certainly do this whole table with your calculator, even by hand you can do it. But I want to show you how to do it in Excel because there's another table later on we have to do some graphing, right? Making graphs. And I know that some of you know how to graph, and please go ahead, do it on paper and take a, scan it in and paste it in to the lab report. But others, they've forgotten about it. You've maybe used it in math and it's been a while. Spreadsheets is a good way of doing it. So it saves you a lot of time once you know how to do it. And if you do other science courses, it will help you too. So what I'm doing here is I put my mouse inside this table anywhere, and then this compass kind of symbol comes up. I select the whole table. I copy it. Then I start Excel, which I should have started before, and I apologize for that. I start Excel, have here a spreadsheet, just make it the right size, and I do Control and V. I hold down the control and press V. And so now I can do calculations in these cells. I hope you can see the green rectangle around those. And so watch also this line because it will show what's going on. So if I'm in this line here and I need to calculate the surface area, I'm going to say equals, and it tells me I need to multiply 6 times the area, right? 6 times around of a cube, 6 times. You saw a little star, and here's my area, and I press enter, and it's 6. And then I need to calculate the volume. Volume is area times length, so I say equals the area here, the one, times the other one, right? That's so far pretty easy. The last part here is surface area over volume ratio. So I've had the surface area here, I have the volume there, and ratio means divide, right? Equals surface area divided by volume. Boom. You can make it a bit nicer. Okay, center it up here. I know some of you know these tricks. But talking about tricks, the best thing comes now. You don't need to do anything else but drag this little handle down, and it will do all the calculations for you. And so you see now that the surface area to volume ratio, that's what we're focusing in here from here on, decreases as the size of the cube increases. And I apologize, I made a mistake up here in this template. You should see 1 over centimeters, right? So that's the whole thing. You select the table, control copy, go back to your document here. You can put, I think we can just put, I'll show you to do this. And you can always move things around, right? Control V, paste it there, and delete the old table up here. Delete table. Okay. And if it starts kind of behaving funny, it has to do with how this table is lined up. You just put some enters somewhere, right? Doesn't have to be a perfect document. I'm not grading you on aesthetics here. So that's all we have here, right? So the surface area to volume ratio is decreasing as the length of the cube increases. The second table is you do the experiment, and then we're going to enter these numbers, these values here. When you do the experiment, as a reminder though, here's your ruler and here's your agar cube, and diffused in, right? Let's say after 5 minutes. The ruler has here this centimeter, and then the centimeters belong to the 1, 2, 3, 4. So the big lines here are the centimeters. The small tick marks and the middle one is 5 millimeters. So these are millimeters. So when we measure from the edge here on the left side, we're going to see there's 1, 2, about 2.8, well, let's be friends, 3 millimeters, right? 3 millimeters, that's the number we are entering. It doesn't mean, 3 centimeters. The centimeters belong to the big numbers here. The small ones are we looking for. So 3 millimeters would be the correct measurement. Just so I can put something in here we can work with. But again, we need to do some math. It's easy to do it in Excel. I select the whole table here, control copy, go to my happy spreadsheet, and do a control paste here. Scroll down a little bit. So let's say I measured here and I put fake numbers. So these are wrong numbers. Say I put here 7 millimeters, which is not possible, right? We have a 10 millimeter cube. I can't do a 7 millimeter, but that way I can show you how to do this and still not giving all the answers away. So I measured 7 here, I measured 7.5, and I measured another 7 here. We also do measurements, by the way, after 10 minutes. So I assume that after 10 minutes, things are diffusing further in, right? It's not a 7 millimeters, so maybe it's, I don't know, 13 millimeters. Okay. And here maybe 12, and here, I don't know, another 13. And these are fake numbers, right? It's not the point. You're going to put your numbers of your measurements in here in millimeters. Okay. Now we need to calculate the diffusion rate. Sounds a scary word, but it means just how fast things went in millimeters per minute. So how many minutes did we put the agar into the vinegar? For 5 minutes. Therefore, we're going to say equals the 7 divided by 5. You're right. And we're going to do the 13 divided by equals 13 divided by, you always put the equal sign there, otherwise it's not an equation. Equals 13 divided by how many minutes? 10, right? Clicking here won't help. Need to enter 10. And as before, I can use the power of these spreadsheets. Just drag it down and we get all the data in the world. We grab the table, Control copy, go back to this one here. I'll usually put some enters here and then enter it just here. You can select that table and delete it. Does it click? Does it not want to select it? It always happens. Can I select it like this? No, now it thinks it's one large table. Yeah, now it thinks it's one large table. Good that the mistake happened. So I do a bunch of undos. So go below here. Make it 2 separate tables. Okay, now I can really deal with it. And now I can see now. I can say delete table. Alright, so don't merge the 2 tables. Alright, we're all there. You get your, what is this, 6 points here, another 9 points up here. You get your 15 points if you show me this work. Should be able to do it. I know it looks easy, but you know, need some practice. Okay, you can answer me then these questions referring to, hey, there's something in table 2, there's something in table 1. Use those to refer to the data and tell me, hey, this is the 1 centimeter cube that has diffused 7 millimeters in 5 minutes, and therefore the rate is 1.4 millimeters per minute. You can talk whole pages out of just these tables. I don't want you to do that though. So then you need to graph, and again, I'll show you graphing the spreadsheet way. You can do it by hand. We need to graph the distance on the vertical axis, so the distance of the diffusion. This thing here goes on the vertical axis, and it asks us to graph the surface to volume ratio, that is this stuff, on the x-axis. So let's do that using the spreadsheet. Swap out things here. Alright, so we have both tables here. What I advise you to do is put those things side by side. Okay, so we're gonna have surface area on the x. I want to double check that one more time. With our instructions here, the distance. So the ratio of the surface area volume ratio goes on the x, and the distance graph goes on the y. And by the way, down here then we're going to put the diffusion rate on the y, and again the ratio, the surface to volume ratio on the x. So that will help us too. So surface to volume ratio goes on x, so I select that data and I put it here. Boom, division by 0, everything is broken. Mr. Z, I'm never going to pass this class. Not right. You just, what you happened here is you entered the equations. G5, H5 doesn't exist, so you say paste, and then you enter, click here, values. Okay, you're just interested in this. So we have surface area over volume here. Okay, and now we need this diffusion distances. We need this one here, copy, Control V, and then times this one, Control V. So this is this distance distance A, right, for 5 minutes, and this is distance B. I shortcut it here. I even don't put units. All we have to do is now we select the whole data. Okay, so you hold your mouse here over SA over V, you drag it along. Everything is then colored beside the first row. Then we go to insert here, and here's one thing. The instructions and a lot of scientific data says use a line graph. However, Excel is kind of a business application. They understand on the line graph something different. Okay, so what we really want is the scatter graphs. Scatter is good. Okay, and if you click here, don't click yet down. You can sense what would come out of it. And if you look below, something's weird. We have two y-axis. We have 3 lines there where we should only have 2. So when that happens, then you go to more scatter graphs. And you can easily see then there's 2 choices here. On the left side it shows you one with 3, where it assumes that your first axis is also a data graph. That's the business type thing. What we really want is the first column, is the surface to volume ratio, and the other 2 are on the y-axis. So we want to pick the one that has only 2. Okay, and that's it. You can beautify it here. It needs a title. It needs axis, right? So to do that, Excel has this add chart element thing. Various versions have different ways to do it. You do a horizontal axis, so this is your surface area to volume ratio, and then this one is your vertical axis. This is your distance, right? And then you put a nice title here, please. Distance versus surface volume area. And then you grab that graph, control, and please grab it like, don't select a data point inside, just the whole thing. Some handles pop up on the outside. Control copy. We go back here. Here goes your graph. Control V. Everything's there. I even have a caption here. So you can, when you talk about this thing, you can say, graph 1 shows. And then you tell me what's shown there, okay? That's what we've just graphed, that's what's shown, but also the shape, right? It looks kind of almost straight, right? It doesn't look like there's a dependency, right? Except some measurements noise. So let's do the other graph, the diffusion rate versus the surface to volume ratio area. So we go back, and that is very elegant to do because we have this graph already. So all we need to do is copy this one down, and this time we're graphing the rates, so these ones here. Copy. So this is the rate A, rate B, and we can make our life even better. Okay, well, I'll show you how. I'll repeat what I did before. It's probably better to do it. Select the whole data, insert, we go to scatter. Not happy because it shows 3 lines, it should only show 2. I say more, I want lines in between, right? I select this guy, and we say OK, and this pops up. Do we have the right one here? No, it didn't look right. Something's not right here. This one is the surface area. Oh yeah, so maybe I really created bogus data here. No. Oh, what happens again was the wrong, the values. I hope you saw that, because this one should be that one here. But hey, we can fix that. And I hope the same things happen for you too, because you need to look at it critically. What have you created? Don't just cut and paste it over. So obviously I made a mistake here, so I need to insert the values. Oops, a good learning. So I go back here, control copy, and then here I say right click, or you go up here and paste, and you say values. Okay, and now it looks like that. I like that much better. The 1.3 did that. Well, it was, oh no, yeah, I made a mistake there too, huh? I should have said not 13, I should have said this value of 13 and then go down here. It's good that I do this, and I didn't do it deliberately, but slight changes, right? Because it will happen to you too. And I insert here values, and this is what we're getting. So We just take this. This time the y-axis is a rate. The x-axis is again the surface to volume ratio. I'll show you one more time, so we need to change those things. You go to design, and that's a key button there, design. If you want to change anything on these, design, add element, x-axis, primary, right? I'm gonna say SA over V, and then the y-axis is here. And Google Sheets is very similar, right? So this is the rate. If you're nice, you say in what did we measure? We measured the rate in millimeter per minutes, right? That's what our units are. We grab that graph and we'll put it back in the lab report. Your graph goes here. Okay, and so you have two graphs here, column graph 1, graph 2 when you talk about it, and try to answer those questions as good as you can, right? Referring to this data that you just graphed here. So that's it for this demo. I'm sure I'm going to do another version of it if I get more questions in, but I wanted to do this. It's not as complicated as doing a whole Blackboard session and loading this and everything. So this is right on YouTube. And let me know if you have any questions. I will do tutoring sessions on this lab too in case you have questions. Please do that lab though. It has a ton of points. We're not doing short answer questions in the test, because I kind of give you this these points here, so you know one assignment is good, and you have your own pace to do it. So do a quality job, get the maximum points, and let's then meet up when we're all done up here at this nice meadow, and it will take a little longer, but grades are almost due. So have a good weekend, and let me know if you have any questions. And bye to you.